In this example, we're going to look at an object that is spinning at a constant rate. So for part A, if I'm trying to find the angular velocity, the only part of this question that I really wanted to emphasize is the fact that I'm giving you the object's rate of rotation in RPM, and we need to find the angular velocity in radians per second for most of our applications. Part A will not be implicitly stated in most problems. You'll have to do this on your own. But I figured for this example it'd be good to show you the steps involved. To find the angular velocity in radians per second, since we know that we have our rate of 300 revolutions per minute, if I just again use my factor label, I know that 1 minute is 60 seconds. I know that there's 2 pi radians in 1 revolution. So if I just look at what I have here, cross off revolutions, cross off minutes, I'm left with the radians in the numerator, seconds in the denominator, which is what I want. So 300 times 2 pi divided by 60, I get 31.416 radians per second. I'm not going to leave this in terms of pi. Most times I will not leave this in terms of pi. I will give a decimal approximation for my answer. For part B, then, the object's angular displacement, since I know it's moving at a constant speed, I know that delta theta equals omega naught t plus 1/2 alpha t squared. That's one of our big 3 equations. So delta theta is equal to 31.416 radians per second times 7 seconds plus 1/2 times 0 radians per second squared times 7 seconds squared. If I use the full equation, this last term will cancel out. I'm left with 0, so I just multiply my 31.416. I'm going to use the exact value from the calculator. And what I'll end up with is delta theta is 219.911 radians. For part C, then, the angular position. What I'm going to have to do is I'm going to have to figure out how many full turns this object has completed in this amount of radians. So if I take the 219.911 radians, I'm going to divide that by 2 pi. And that will give me the amount of revolutions that this has taken. Just be careful in your calculator. Make sure that you put parentheses around 2 pi when you're dividing. Otherwise, you'll divide by 2 and then multiply by pi, and you won't end up with the right answer. So if I do this, if I divide this by 2 pi, I end up with 35. So actually, this is kind of convenient. It's 35.0. So 35 full revolutions. What this means is that I'm starting at 0, so I'm going to end at 0. So it's either 0 degrees or 0 radians. I'm back where I started. If I were to give you a different value, what you'd have to do is you just have to take the radians, divide by 2 pi, you'd figure out how many revolutions that is. You're going to have to look at your remainder. So whatever your remainder is, you multiply that by 2 pi, and that will give you the object's exact position in radians.